Guys, Professor Griffin, lesson 9 Python crash course. This time we're going to talk about lists. So a list is in Python is like an array, but it has so much more going for it. So we can declare a list just by assigning it square brackets. That basically makes it a list, but I can also put values in there right off the bat. Print list. So remember, in C or C++, you try to print a list out or print an array out just by passing it to a function. Well, you better know how long it is, and there's a lot more going on. So this is really convenient. Lists do not have to hold the same data type. So I could, in this list right here, put bubbles 8.9, another list. It doesn't, it's just a container, and when we write print list, it'll still print everything out like no big deal. In fact, we can still treat it like an array. Instead of printing list and printing the whole thing, I could pick a subscript. Let's go, what is that? 0, 1, 2, that's 6. Print out bubbles, list sub 6. Oh, I missed. Yeah, 0 subscripting. I'm a genius. So there's bubbles. So the list doesn't care what's in it. Sometimes though you have to be careful, because no matter what data structure you use, you still have to iterate over it. So let's iterate over this list and print every item out one at a time instead of just using a default print function. So remember our for loop, for like item in list, and so what this says is, so for every iteration I'm going to pull one item out of the list container and store it in this variable. So I can say print item. So now we access each of those items in the container one at a time. Let's manipulate our list. I can say lst.append. Let's just put another number in there. And oh, I didn't print it afterwards. There's our 99. Let's take this off. Let's take bubbles off. Let's just make this a more respectable, conventional, simple list. So we can still, let's append 6. But now what if I have list, let's make this 1 and this list 2, and then list 1 we want to append to 6. List 2 is really 10, 11, and 12. I need to make it a list. Okay, so here's let's put this list on the end of list 1. So list 1.append list 2. And let's not iterate over these, because it's graphically more appealing when you see it like this. Print list 1. Graphically, I don't even know what that means. Notice how we have an initial list 1 through 6. We have another list 2. List 1 we appended 6, so we got another 6. So it was already there, so it didn't complain. And then I said list 1.append, well, list 2. But since it's a list, well, it just stuck it on there. And that's okay as well. And this is actually how we'll eventually store 2D data. But there's another method on lists that will maybe do something where you thought this was going to happen. where we extend the list. So there we go. Let me clean this up a little bit. There we go. So yeah, we took list 2 and we extended list 1. And that just means take all the items in list 2 and individually append them to the list. We can also remove items. lst.remove. But this isn't going to work how you think it's going to work. So let me put that on pause for a second. Let's say lst1.pop, and let's get the p is equal to lst1.pop. Print the list, print p, and let's see what happens. So pop removes the last item off of a list. Makes sense, right? But pop is a method that will let you send it a value, meaning an index value, and that index needs to be valid. So now we basically shifted off the first item in the list by passing it in a specific index value. My list is already sorted, so I kind of screwed myself there. So let's do this. Let's say list 2 and list 1, and let's see what happens. So now we've got kind of like this, not totally in order, but what I can do is say lst1.sort, and it should be an in-place sort. And there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Meaning in place means I don't have to return the resulting sorted list so that I can assign it to something else. Oh, and check this out. Let's not print that anymore. lst1.reverse. Print list1. Man, there's so many things with lists, and I'm trying to go fast. So yeah, it just reverses it for you. Alright, so what does this remove thing do? Let's come down here. List1.remove. Let me put in a 4, and then let's print list1 again. So what do you guys think happened? So 0, 1, 2, 3. Dang it. It's not an index. So let me put in the 11. How did I do that? So what remove does is it goes and finds the value 11 and removes it. Not that and I chose index 4 and 4 happened to be at that, so that was confusing. So yeah, remove finds the first value with the first item with that same value you pass in, and it removes it. Alright, here's something cool. Alright, so let's say I have list 3 now. Let's do it up here. I'm going to say list 3 is equal to the entirety of list, list 1. Okay, I'm not going to print any of this stuff out anymore for now. So I just said list 3 is equal to list 1. We've already manipulated list 1, but let's print out list 1 and let's print out list 3. Okay, as expected, I assigned them to each other and they're the same. Okay, so let's do this. Now we're going to say list 3 sub 0 is equal to 99. What? Yeah. So there's this thing in Python called a deep copy. Now, so what happens is, this is almost like a pointer. So list 3 really just points to list 1, and when you said list 3 sub 0 gets a 99, well, it gave them because they're pointing to the same place. Now there's a way around this. We can say list 3 is equal to a list 1. So list is actually a function that you pass an iterable container to, and it will do this so-called deep copy thing for you, so that now, okay, we assign it the 99 to list 3, it doesn't affect list 1. Man, there's so much more. I'm gonna just break this up into another video. Alright, see you in a little bit.